So what I'm gonna try to show you here is how machine learning and specifically how CopyCat can help us to quickly compose some shots, specifically do some effects. So sometimes in the prep stage before we applying the effect itself. So like some technical work between A to B, or even like creative effects. But what is happening here with CopyCat and machine learning itself and 2D world or images, how we compositor deal with pixels, with image. So what happening here is we can specifically train CopyCat models to attack specific tasks that we have on some shots, because even sometimes we have these effects, they are pre-built to do something, and then we somehow have to be creative in how to use those effects, because shots change, because every time clients have some decisions, and we are dealing with a bunch of variations, so it's hard to predict how the shots are going to be. So having pre-trained models, it works perfectly as well, but sometimes you really need specific training, and this is where CopyCat gets very useful, because we have this particular shot or particular effect, or even this particular task that sometimes pre-built effects doesn't work, because maybe the lighting on that, or even that specific movement on that particular shot, it doesn't work any plugin. But then we have to be creative, and machine learning and CopyCat can help us to train specifically to that task. So that's what I'm gonna try to show you here right now. So here I have the shot, and this is a shot that I worked a few years ago. And what was special about the shot is how many layers of photos we have to comp on these shots. And what is happening is every time we move, let me play the shot. Every time we move, you see like variations of lighting, variation of shadows. Even here, you have variations of, the perspective of the tracking markers. So all these red tracking markers we need to remove in order to compose these pictures on top. And there is a bunch of ways to approach this shot. One of them is trying to clean these tracking markers and in a very realistic way, so we can keep all the lighting. Like if you see in here, we have this big lighting happening there, but not here. So if you can clean this up, and like even in this in the shade, and just have a clean plate of this without tracking markers, we can use these lighting variations to compose on top of the pictures. And this is exactly what's happening on this shot. So in order to make this shot realistic, we need to make sure that we have the lightings, and in some frames here, for instance, if you see here, you have the shadow of the finger, but you have this strong mid to highlight effect happening. So these variations it's great, because when you put this on top of our digital photos, we have this we make more realistic because of this particularly real world effects. So we could, before machine learning and CopyCat, we could easily, go in here and go tracking markers by tracking markers. And then what we can do is place that and manually removing one by one, and then remove this manually. So as you can see here now, I'm going to apply traditional 2D effects. What I'm going to do is trying to patch the surround area, and then quickly removing the original tracker markers, and we usually do in this way, and then we trying to get the best pixels surrounding, and then in the combination of all of those tracker markers, we have a pretty nice clean plate with all the effects of the real light environment. But what's happening here, as you can easily see, this will take a bit of time, and I remember doing this shot years ago, and this took me a good solid days, because I was looking to have all this tracker markers removed. So what all these techniques of machine learning is allowing us is to doing this same task very fast. And we do have like approaches like imaging painting, or even approaches with GAMs to trying to patch this with a mask and then get its surroundings and then clean. But even sometimes if you have a good pre-trained model, that can work really nicely, but we still sometimes want to perform specific to a sequence or a shot or a specific frames. This is where CopyCat getting very useful. So in thinking the same way of having a data set, I could easily take this shot here, and then crop all the tracker markers, and then clean a few frames, and then train a model. So that is usually what we try to do with machine learning. So we have our original shot, and then we can have a ground truth, and then we hopefully, when this is very well training, the model will be learn how to reproduce these results. And this was manually clean. But what's happening with this approach, which is amazing, is we, as a compositor, we'll have more tasks to do. For instance, we will need to cropping all the images, and then try to maybe align each one, and then have all the best variations and so on. And with CopyCat, we even don't need to do that specifically by cropping and prepping. We can jump that stage and perform what I did here, just a few frames. So what I did, I choose 5 frames between this shot. It's 52 frames long. So I choose 5 frames where I get the most variation as possible. And then you can see those frames here. And what I did, I take the original, and then I clean this frame. And then I take the second frame, and then I clean as well. The third one, and then I clean. So I did that for 5 frames. And then now I have a data set for CopyCat. And what is the beauty of this is that I don't even need to crop and prep and align, because I can train in kind of a difference mode. So I'm gonna put the shot as it is, and then just train with these frames. And then when I apply the model that was trained, I'm gonna just apply on the shot without worry about cropping, without worry about coding or prepping, and that is really, really helpful. So here, as you can see, I have my model, and then I'm using two RTX 8000s, and then I'm using that to train the model on those 5 frames. And I did that a few times, as you can see here. And then that is also great, because we can start the training, and then you can stop the training, and then I can just inference that, see the results, and continue working. And that is exactly what's happening right here now. So I trained the model. I training and stopped training around 10 to 20K. And then I figured out the best result was this one. So I was quickly just stopping, testing, continuing training. I got my model and then I'm just inference right now, and this is real time. That for me, it's the best. So you see that the model, this is running the model also with the same RTX 8000s, and then when I just hit play, the model starts to just cleaning almost in real time. So this is running kind of live right now, and yeah, this is working. And what is great for me is that I just fed the model with 5 frames, and then now it's applying and pretty much done. I remember having this spending days on this approach here in order to get, but now I'm just training. And what is great about this is we can do other tasks while the machine is training. So we can put this for training in another machine or overnight, and then we can have kind of this as AI machine learning assistant. And this is exactly what's happening here now. And then you see that is removing and keeping the surroundings. Another thing that I really like of this approach, it's the ability of have more, we train the model, and if the model is very well trained with a good data set, and remember this was just 5 frames, so this could be even better if I have more frames to the model for training. But with those 5 frames, imagine that we have this shot, and I'm gonna apply some augmentation on it, so some transforms. And so here I'm applying some rotation, some scale with some rotation. So this for the model, it should be a completely new frame. And then what's happening is when I apply the model here now, let's apply the same model. It's just it's just apply again. Let's put another frame, and then you see that it's all clean. Let me remove. See there, and let me apply the grain. So finish this comp, and let me compare to the original one, which is before the transformation, and then after. You see what's happening. It's really removing, or if you want to really compare, so I can apply the same argumentation to the original one, and then you can compare like that. And you see, this is a completely new frame, new, you can even say new shot. And then when we compare very closely to that and the original one, it's very much clean. And this in the past took me a long time to do it. And yeah, this is really great to have in comps right now, especially for prepping stages like this one, and really helpful, especially if you have a good hardware for training and speed up the process. Let's remove this transformation, and now let's do this even harder. Imagine it. We do have AI machine learning models to do retiming. We saw in the past, like NVIDIA doing these amazing approaches to do retiming. So imagine if you retime this shot. So we're gonna create frames that we never saw before, and this is so when I apply a retime here, I essentially creating completely new frames, because this is low down for different speeds, as you can see. So go faster, go slow. So for instance, if I put some keyframes here, let's actually create this right now. So let's kill keyframes. I'm gonna create some handling. So here I'm gonna slow down. So here I'm going to speed up again. Let's speed up more. So, and here I'm going to slow down this again. So you see that it's because this is based on an optical flow, a traditional method of applying and create completely new frames, sometimes this does create some artifacts. So what's happening here in this between frames is we are creating a completely new frames that was never planning to have it. And so if I wanted to do this manually, I would have to just redo it a shot again, because all my manual masks like I had here and all my scales, everything would be completely different. Imagine by doing this slowdown or this time warp, we are just completely having a new shot. And when we try to apply the model, it's just remove it. This is a completely new frame. When I pass, you see it there? You can see by having these artifacts, we know for sure this is a very new frame. And you see the model is trying to remove. Even with the artifacts, you see there, these artifacts happening there, it's actually removing as well, because the model was trained to remove this type of pixels. So why not the artifact and actually working? So when I apply the grain, just matching the grain from the original, we pretty much have it clean, which for me, this is really amazing, especially for artist's perspective, that we can, you see what I just did here. Even let's push even more and create like argumentation on the shot, and you see, it's just do it again. And if I want to render this in real time, applying the retiming and then having the whole thing, it's just doing it. So this is really, really powerful in creating a completely new way of approaching the shots, because it gives us the ability to work, to train a model specific to the frames that we need to be working, or sometimes you're dealing with shots that we need to be very, very be careful about it. So having a model that we can train on our own and this is really on and very specific to those frames, this changed the workflow completely. And that is where CopyCat came, because this is really great, and for sure, not only for this, but other tasks we'll be able to apply effects like that. So yeah. So also another thing that we could do is imagine that this is a 3K shot. So depending of the hardware and computer that you have, this can be very difficult to work it on, because it's very heavy, especially if you have to do not only this, but you have to do the whole comp, and that can be very heavy. So a good way to approach this with CopyCat, it's training is specific to this shot or even to the whole sequence, but training to upscale those pixels. So what you can easily do here, for instance, is I have this a native 3K resolution, and then what I can do is resize this for full HD. So let's resize this like 0.5%. So let's say I want to this and half. So now this is half resolution that we had before. You see that you're losing a lot of definition because you're now half of the percent here, like it's not even 1080p anymore. So this allows to be very, very applying effects really, really fast. So what we can do here now is adding a CopyCat, and make sure that my ground truth is going to be the original one and my input is going to be my resize one. And now what I can easily do is it's training. So CopyCat is going to be training with ground truth, the original one. And when we zoom like that, let's see those record marks that has resolution. And this one, which lost a lot of rest. And then now I can just put for training quickly. And since I have two RTX 8000 here, I can just push this to looking for details. And let's clump this. Since we have 2, let's add off, so bed size of 25, and then I'm training a model to just to understand the difference of the resize specific to that shot. And then if this is well trained, as you can see here now, it's trying to understand the differences, as you can see there. And then once this is well trained, we'll be able to just resize in the end, so we can do all our effects in the not very small, but in the small resolution, and then quickly compose the shot and then apply to upres again and make the shot even faster. So that's it. Hope you have enjoyed, and thanks Foundry, and thanks everyone. Thank you. Bye.